we're going to spend some time converting equations from polar to rectangular and rectangular to polar. So we're going to take a look at a few examples here. Very easy to do. You just have to remember the formulas from yesterday. So for like number 1 here, it says, the rectangular equation, x equals 3. Remember, this is a vertical line, x equals 3. And I want to write this in polar form. Well, all we have to do is, if we recall from yesterday, what x was equal to. In polar form, x was equal to r cosine theta. And so I could write this as r cosine theta equals 3. Now, we do want to solve for r, so r is just 3 divided by the cosine of theta. If you want to get real fancy, you can say 3 secant theta. You don't have to. Let's take a look at number 2, where it says x squared plus y squared equals 16. Well, that's a circle, and in polar form, I want to convert this to polar, just recall what r was equal to. R was equal to the square root of x squared plus y squared. So if I square both sides, r squared equals x squared plus y squared. Remember, if you want to go to rectangular to polar, you have to have no x's or y's. You want it in terms of r and theta. So we want basically r's and thetas. And I can do that here. X squared plus y squared, that's r squared equals 16. And in polar form, this is a circle with radius 4. Very easy to do. Let's try number 3 here. Number 3 is a line. How do we write a line in polar form? Well, remember, x is r cosine theta, y is r sine theta. And I'm just going to plug those in. We get 3 r cosine theta plus 5 r sine theta, and that's going to equal 7. You may be thinking, now, how do we solve for r? Well, both terms have an r. We can factor it out. 3 cosine theta plus 5 sine of theta equals 7. R equals 7 over 3 cosine theta plus 5 sine of theta. All algebra there. So try that one again if you need to. Number 4 here. Forgive the scratch out right there, my own scratch work. Sorry, when I ran out of extra copies. So when we take a look at number 4, it says x squared. Well, remember, this is just going to be r cosine theta squared equals 5r sine of theta. If I square it, I get r squared cosine theta squared equals 5r sine of theta. Now, imagine if I took the square root. I would like to take r squared equals, 25. If I take the square root and I take the radius, remember, radius is a length. We would normally get a plus or minus, but because radius is a length, we only take the one answer. Now, because of that, I can actually divide both sides by r. Normally, we would never do this, and if anybody ever tells you otherwise, we cannot normally do this because normally r could be a plus or minus, so we can never just divide by an r because you lose one of the values. But because we're talking about radius, it has to be positive, so we can actually divide by r here. So we get r cosine theta equals r's cancel here, cosine squared, 5 sine of theta. And I can write my answer as r equals 5 sine of theta over cosine squared of theta. And if you want to have fun, you can even have more fun. You can write this as r equals 5 sine over cosine is tangent of theta, and 1 over cosine is the secant of theta. Either one's acceptable. All right. For number 5, forgive the scratch outs there again. If I try this one, remember x squared plus y squared is r squared, and 8 is just 8r sine of theta. And like before, I'm just going to divide both sides by r. R equals 8 sine of theta. And there's our function. And by the way, this is a circle. That's a circle too, which we're going to talk about tomorrow. That's tomorrow's lesson. All right, now how to convert from polar to rectangular, a little bit tougher to do. Here they give me theta equals 30 degrees. Well, recall from yesterday how we get theta. Theta is the inverse tangent of y over x. So I could write it this way. 30 equals the inverse tangent of y over x. So if I do the inverse of this, we get y over x equals the tangent of 30 degrees. And we should know the tangent of 30 degrees is 1 over the square root of 3. So therefore, we get y equals 1 over root 3x. This is slope. Now what's very important for this is, guess what? Slope is the tangent of an angle. And that's what it's kind of telling us. That slope is the tangent of theta. If you want to find the slope, find the tangent of an angle. Very easy to do. All right, now let's try this one. R equals negative secant of theta. So I'm going to rewrite this. Don't like secant. This becomes negative 1 over cosine of theta. Now I'll notice, oh look, if I were to cross multiply, I get r cosine theta equals negative 1. And what is r cosine of theta? That's x. That's just x. R cosine of theta. Remember, x is the r cosine of theta. And that's from our trig values from yesterday. So x equals negative 1. This is a vertical line. Very easy to do. Kind of fun. So let's try number 3. Ooh, that looks ugly. Cross multiply. I get 5 equals, watch this, r 4 cosine of theta plus 6 sine of theta. And do you notice what you can do? Yeah, that's right. Distribute. We get 4r cosine of theta plus 6r sine of theta. Simplify. 5 equals, that's x, so we get 4x plus 6, and r sine of theta is y. So we get 4x plus 6y equals 5. This is a line. Very easy to do. Kind of fun, actually. Some people really like it. All right, try number 4. Again, cross multiply. I get 1 equals r minus r cosine theta. So let's think about how we can do this here. I can now write this as 1 equals r minus, and what does this become? R cosine becomes x. Now here's the problem. I have r and x in the same problem. We won't worry about number 5 here. Kind of running out of room here. Recall what r is. R is nothing but the square root of x squared plus y squared. So I could write this as 1 equals the square root of x squared plus y squared minus x. Now I'm pretty much done with this. I got rid of my r's and I got rid of my thetas. So I do like this, but I don't like the square root here. So what we're going to have to do is square it. But I don't want to square it like this. That becomes very ugly. I'm going to bring the x over. So I get x squared plus y squared equals 1 plus x. And now I can square it. Both sides. I get x squared plus y squared equals, if I square here, this becomes 1 plus 2x plus x squared. Combine your like terms. Take a look here. Look what cancels. Oh, look, if I bring the x squareds over, those two cancel. That's kind of nice that those canceled out for us. And what am I left with? We get y squared minus 2x equal to 1. It looks like it's going to be a parabola for us. That's the equation of a parabola. Now, if you want to, you can go and try number 5. I'll tell you, try number 5. Sorry, I scratched it out. Remember, it was 6 over 2 minus sine theta equals r. We'll go over this one in class tomorrow, okay? So make sure you try that one, and then go on to part 2.